Before moving on, I want to talk a little bit about why all objects fall at the same rate. Now we said regardless of the object's mass, it's going to fall to the ground at the exact same rate. Meaning, if I dropped a baseball and a bowling ball off of a building, they're going to fall at the exact same acceleration and therefore hit the ground at the exact same time. Now that kind of goes a little bit against intuition. You would think that the heavier object would actually fall quicker because it's heavier. But it turns out that that's not the case. Now, it's not the case in an idealized way. So what I mean by that is if we're just looking at the force of gravity, both objects will hit the ground at the same time. If we start factoring in the drag due to the atmosphere and other forces, then that kind of complicates the problem. But so in this discussion, we're strictly talking about just the force due to gravity. Now, let's look at these two objects. We'll say that we have this bowling ball, right? And we also have a baseball. We're saying that they fall to the ground, they fall downwards at the same rate. And you'll learn later on of Newton's second law of motion. So Newton has 3 laws of motion, and the second one says that the force that an object feels is equal to its mass times the acceleration that it's undergoing. Okay, so both of these balls undergo this equation. For the case of the bowling ball, we're saying that the mass in this equation is bigger than the mass of the baseball. And if we're saying that the acceleration is the exact same in both of these equations, then since m is big, it's going to make the force big on the bowling ball, or at least bigger than the baseball. And then we're also saying that the mass of the baseball is small, and therefore that makes the force in this equation small. And so even though this bowling ball has a bigger mass, it is going at the same acceleration. But we see that the force is bigger on the bowling ball than it is on the baseball. And if we divide through by m, we see that the acceleration that the object feels is equal to the force divided by the mass of the ball. And that's the same on both of these. And again, this acceleration is, we're claiming, constant. And it kind of makes sense because as the mass gets big, let's say here, so does the force. And so this ratio, this force to mass ratio, is staying the same, even though that the mass is small here and the force is small. You can have 2 small numbers and 2 big numbers, but they could be the exact same ratio. And that's what's going on here. Since the bowling ball has more mass, has more things that the Earth needs to pull down, it requires a bigger force to accelerate it as much as this baseball that doesn't have as much mass and much matter inside it. So for these 2 balls to have the exact same acceleration, the Earth needs to pull this one a little bit with a little bit more force to equal the same acceleration as the baseball. And that's why both of these objects accelerate to the ground at the same rate.